Here's the review video of the functions, operations, and inverse group quiz that we did. So starting out with number 1, this is when composition of functions. So on those, again, we always want to start out with the inside function. So in this case, we really need to be finding g of 2a minus 1. Okay, so to do that, what I'm going to do is look at the rule. The outside function is g, and here's kind of the format for g of anything. It's 3 times the thing plus 2. So to do g of that, we're just going to follow that format of g of a is 3 times that format, 3 times 2a minus 1 plus 2. Okay, I simply just plugged in for that a right there. And now all we need to do algebraically is simplify this. So distributing the 3, we'll get a 6a minus 3. And there's a plus 2 out there, which should combine to be 6a minus 1. Okay, moving along, number 2 here. We are doing adding functions together. So g plus h of x. We're just going to simply take the 2 function rules, add them together. I don't even worry about parentheses with addition, because all we're going to do is combine like terms. In this case, x squared is the only squared term, plus x is the only x to the first or linear term, and then the 4 plus 4, of course, is 8. And there's nothing else we can do. That is g plus h of x. Okay. One note, remember, we're not multiplying by x here. This is just simply telling us what the variable is. So it really doesn't affect our answer. Okay, moving along to number 3. A couple different ways to do this. This is a multiplication. It's f times g of negative 4. So one option is to actually multiply the rule for f and the rule for g. Okay, which would actually involve foiling this or distributing, which would start out n to the third and so on. But since they gave us the value for the variable, I'm going to do it a little differently. I'm going to plug in the negative 4 first before I multiply. Okay, it might just make it a little bit easier to calculate the answer in the end. Okay, so that's all that means. That out there just means that's the value of the variable. And then we'll simplify each. So negative 4 plus 3 is negative 1. The other piece, we have negative 4 squared. So be careful, that is actually 16. And then 2 times negative 4 is negative 8. So plus negative 8 is really like minus 8. And this simplifies to negative 1 times 8, which is negative 8. Final answer. Okay, moving on to number 4. We need g over f of x and stating the excluded value. So this one's a pretty quick one. To do the fractions, all we're going to do is just write it in the correct order. It's g over x. G over f. So g is x minus 4. The rule for f is x plus 4. Okay, so that's the function. Okay, that's a 4 there. Now the other part, any excluded values, those come from anything that would make the denominator 0. Okay, because we cannot divide something by 0. So you always need to figure out which value would make the denominator 0, which in this case, x plus 4 cannot be 0, so subtracting 4 would give us x cannot equal negative 4. So that's kind of the second part here. We have the simplified expression and the excluded values. Okay, moving on, number 5. This was the... All right, so moving to number 5 here. We had a discount on televisions, $50 off, Thanksgiving sale, and then the 6% sales tax. So we got 2 things going on. So the sale is $50 off. So if we want to write a rule for any price, where P is the original price, all we need to do is take that price P, and we're saving $50. So minus $50. Okay, so that's S of P. Then for part B, we now need to add sales tax. So if tax is 6%, the rule to add tax to any price P is to just take the price and add 6% of it, which is 0.06p. Okay, and it's going to be a little simpler for us if we combine those like terms. P plus 0.06p. Okay, remember P is 1p, so when we add the like terms, we're going to get a simplified rule of 1.06p. Okay, notice I'm not doing anything with the $50 discount. This is just to add tax to any price. All right, now part C, we're gonna be doing the sale and tax in different orders, okay? So you gotta watch. On this one, the sale occurs first because it's the inside function. So T of S of P, again, the way we always do composition is replace the inner function. S of P, we wrote in part A, is equal to P minus 50. So if we want to apply the rule T now to P minus 50, what I'm going to do is plug in P minus 50 for that P. Okay, and in this problem as well, they actually gave us a value to use for P. So now might be a good time to plug that in. P we know is 800. Okay, so we need to do 1.06 times 800 minus 50, which is 750. So we're going to do 1.06 times the $750, which should get us a final answer of around $795. Okay? So again, that's doing the sale first, then applying tax after. Okay, then when we switch things up now and add tax first, okay, because T is the inside function, that always occurs first. The rule for T of P is, from part B, we said is 1.06p. Okay. Now we look and say, all right, how do we do S of something, right? S of anything is just the thing minus 50. So it's 1.06p with a minus 50 afterwards. Okay. And then again, we know P is 800. So 1.06 times 800 minus 50. That gives us an answer of $798. Okay, so it was better. It was in our interest to do the sale first. Okay, because if you think about it, if you do the sale first, you're paying tax on a smaller amount. Okay, and it made a $3 difference. So so the order is important when you do composition of functions. All right, now moving along to the back, we need to find the inverse and then prove things are inverses. So to find the inverse of a function, all we need to do, a few steps, it's better to replace f of x with y. So think of this as y equals 2x minus 5. And then the idea with inverses is that x and y are going to end up switching spots, okay? So we're going to rewrite it as x equals 2y minus 5. And if we can solve that for y, we will have the inverse. So we're going to add 5 to both sides. Okay, so x plus 5 equals 2y. And then the last step to get y by itself is to divide both sides by 2. And it's probably simplest just to divide that whole side by 2. Okay, that is the new inverse. That is what we will call f inverse of x. Okay, and the final thing on this was to actually prove two functions are inverses of each other. Now this one looks kind of weird because f and g are the same thing. But in order to prove functions are inverses, we're going to need to show that when we plug one into the other, we get x. And when we switch the order, plug f into g, we also get x. Okay, now we're going to get lucky in this case because f and g are the same, so both of these are going to be equivalent. So I'm just going to do one of them. But basically the idea is, again, when we want to do f of g of x is negative x minus 1. Okay, so the trick to doing composition, again, is go back and look. What's the rule? F of anything is just negative x minus 1 in this case. So it's going to equal a negative on the outside, then this entire expression, and then a minus 1 out there. Okay, and what we want to do is simplify it, distribute the negative sign. Negative negative x is x, negative negative 1 is plus 1, and there is a minus 1 sitting out there, so this direction does equal x. Okay, that's what needs to happen. This would be the same thing. Okay, and since we've shown both compositions equal x, we have proven that they are inverses. Okay, if we would have got anything other than x, we would say no, they are not. So hope that helps. Good luck.